Okay, so if you can turn to page 19 of your packet, we're just going to talk about something called the Pythagorean identity. All right, so what you see here is we have, this is going to be the unit circle. All right, so we have the unit circle drawn here, so it goes at 1 unit in each direction from the origin. So what I'm going to do is I'm just going to draw a point anywhere in the unit circle. It doesn't matter where. You can do this on your paper too. And you're going to take that point and connect it down to the x-axis, and then also connect that to the origin, and then you can just connect those two lines to make a right triangle. Now we don't know the coordinates at this point, so I'm just going to call that x, y. We're just going to keep it general. Alright, so to get to that point, what we did was we went over x units, and we went up y units. So the length of this side of the triangle would be x, and the length of this side of the triangle would be y. Now, since this is the unit circle, right, it extends out 1 unit in each direction, the length of the hypotenuse here has to also be 1, because our circle, no matter which direction you go out in, it has a radius of 1. All right, now here's why it's called the Pythagorean identity, because we know that a squared plus b squared equals c squared, right? That's your Pythagorean theorem. So let's write that out over here. So a squared plus b squared equals c squared. So, in other words, it doesn't matter whether you make this a and this b or vice versa. So I'm going to make this a and this b, and then c is your hypotenuse. So that being said, let's substitute the a with a y, the b with an x, and the c with a 1. So we could write y squared plus x squared equals 1 squared. Now, since we know that the y value corresponds with sine of our angle, and since we know that the x value corresponds with cosine of our angle, we can substitute the y and the x with sine and cosine. And don't forget to put the squares on there. So in place of the y, we're writing sine squared of our angle, and then plus, in place of the x, we're going to put cosine squared of our angle, and then you could bring down the equals. Well, 1 squared is just 1. So this right here is the Pythagorean identity. Sine squared of an angle plus cosine squared of that same angle equals 1. So, I mean, if you want to check it out, you can try it in your calculator. You can pick an angle, right? Sine squared of, 45 plus cosine squared of 45. Okay, you can plug that in your calculator, and when you hit enter, it should give you 1. One thing I want to point out, when you plug sine squared of 45 in your calculator, you actually have to plug it in as sine of 45. Okay, it'll open up a parenthesis. You have to put the squared on the outside when you plug it in your calculator. Okay, so let's take a look at some examples. Now, 34, it says, given that sine squared theta plus cosine squared theta equals 1, and sine of theta equals negative radical 2 over 5, what is a possible value of cosine of theta? Now, we know we could do this using bow tie triangles. I mean, we've created bow tie triangles to do this before, but we're going to use the Pythagorean identity to do it. So, if we know that, I'm just going to write this out, sine squared theta plus cosine squared theta equals 1, since they give us that sine of theta is negative radical 2 over 5, let's just replace that for the sine of theta in our equation. So I'm going to replace sine of theta with negative radical 2 over 5, and we're going to put a square on the outside because it's sine squared of our angle. And then we don't know cosine of theta, that's what we're looking for, right? And we'll bring this down. So we could just solve this equation for cosine of theta. All right, so if we square the negative rad 2 over 5, well, the negative squared, negative times negative is positive, and then you just square the numerator and square the denominator. So if you take radical 2 and square it, a square and a square root cancel each other off, so the numerator we're just going to have 2. And then in the denominator, 5 squared is 25. And I'll just bring down the plus cosine squared theta and the equals 1. So what we're trying to do is we're trying to get cosine of theta by itself. So in order to do that, let's get rid of the 2 over 25. So that leaves us with cosine squared theta equals 1 minus 2 over 25. So basically 1 is 25 over 25. So 25 over 25 minus 2 over 25 would be 23 over 25. Okay, so 1 minus 2 over 25 is, that's a really bad 3, 23 over 25. And then finally, just to get rid of a square, okay, we want to get rid of the square because we don't want cosine squared theta, we just want cosine of theta. Okay, what's the possible value of cosine of theta? So to get rid of the square, we just take the square root. I'm kind of running out of room, so I'm going to come over here. So that leaves us with cosine of theta equals. Now, when we take the square root, the square tells us that we can have two answers. So we're going to write plus and minus. And when you take the square root of a fraction, you individually take the square root of the numerator and the square root of the denominator. Now, okay, so that leaves us with cosine of theta equals plus and minus. Now, the square root of 23, I mean, that's not going to simplify it for us. There's no perfect square that divides evenly into 23, so I'm just going to leave that as radical 23. But the square root of 25 is just 5. So when they say what is a possible value of cosine of theta, you could either get positive radical 23 fifths or negative radical 23 fifths. If they told you, for example, we were in quadrant 4, we know cosine is positive in quadrant 4, so it would be positive radical 23 fifths. If they said that we were in quadrant 2, we would know that cosine is negative in quadrant 2, so it would be negative rad 23 fifths. So anyway, in this case, the answer is positive radical 23 over 5. Okay, so I want to skip ahead. If you can look on page 20, there, I guess I don't know how to number the packet. There's 2 number 36s. We're going to look at the second one, the one in the middle of the page. It says, using the identity, sine squared theta plus cosine squared theta equals 1, find the value of tan theta to the nearest hundredth if cosine of theta equals negative 0.7 and theta is in quadrant 2. Okay, so what they want us to do is, it says using the identity. So we're going to have to use, the identity, sine squared theta plus cosine squared theta equals 1. And they want us to find tan of theta. Now, tan of theta isn't in this identity, but we do know that tan is equal to sine over cosine. So tan of theta equals sine of theta over cosine of theta. Okay, so I mean, our ultimate goal here is to find the value of tan of theta. So we know we're going to have to use this equation. And we know what cosine of theta is equal to because they give it to us, but we don't know what sine of theta is equal to. So that's why they want us to use this equation, right? It says using the identity. So if we substitute what cosine of theta is equal to in here, we can solve for sine of theta. So let's do it. So I'm just going to bring down the sine squared theta because we don't know what that's equal to. But since we know that cosine of theta equals negative 0.7, that's what we're going to replace for cosine of theta. And we're going to square it because there's a square in the equation. And let's just solve this. All right, so we have sine squared theta, and then plus, all right, so negative 0.7 squared is just positive 0.49. So let's bring that down. And since we're solving for sine, we're going to need to subtract that from both sides of the equation, the negative 0.49. So that gives us sine squared theta equals 0.51. And to get rid of a square, we take the square root. So we know we're going to have sine of theta equals, don't forget the plus and minus, radical 0.51. Now, here's the thing. This is really important, actually. It tells us that theta is in quadrant 2. So you have to think about, in quadrant 2, is sine positive or is sine negative? Well, in quadrant 2, sine is positive. So really, we can kind of disregard this negative answer here, right? We could say that sine of theta has to be equal to positive radical 0.51. So this radical 0.51 is what we could substitute in for sine, and this negative 0.7 is what we could substitute in for cosine. Now, one thing I want to point out is it does want us to round in the end to the nearest hundredth, but I don't want to round this yet, because why round in the middle of the problem? That might throw our final answer off. So let's leave it for right now. So tan of theta is equal to, for sine of theta, we're going to replace it with radical 0.51, and for cosine of theta, we're going to replace it with negative 0.7. And then, I mean, really, all you're going to do is plug this in your calculator, and this is what you're going to round to the nearest hundredth. All right, so that leaves us with tan of theta equals, and then to the nearest hundredth, it's negative 1.02. Okay, what I'd like you to do on your own now is I'd like you to go back and try the ones we skipped, so number 35, the first number 36, and 37, and we will go over those tomorrow in class.